The Codec Registry maintains a mapping of type identifiers to serialization and deserialization functions. Each codec implementation must conform to a standard interface accepting input streams and returning decoded objects. The registry uses a hierarchical namespace system to organize codecs by domain, reducing collision probability and enabling logical grouping of related serialization strategies. Registration occurs through the register codec function, which accepts a type identifier string, a version number, and function pointers for encode and decode operations. The system enforces unique type identifiers within each namespace. Attempting to register a duplicate identifier with different function signatures returns an error status and does not modify the existing entry. Type resolution uses a multi-step lookup process. First, the system checks the local namespace cache for a matching identifier. If found, it validates the cached version against the request context. If not found or version mismatch occurs, the registry queries the backing store using a linear search through registered codecs, returning the first match with compatible version constraints. Version compatibility is determined through semantic versioning rules. A codec version, major.minor.patch, is compatible with requests specifying the same major version and a lesser or equal minor version. Patch version mismatches do not affect compatibility. The system logs version resolution decisions when the verbose resolution flag is enabled in the configuration structure. Codec implementation requires two function signatures. Encode takes an object reference and output stream handle, returning a status code and byte count written. Decode takes an input stream handle and target buffer, returning status code and bytes consumed. Both functions must handle partial stream conditions gracefully, documenting their behavior in implementation-specific documentation. The encoding process begins with a type header containing the identifier and version number in binary form. Following the header, the codec writes domain-specific serialized data. Buffer overflow protection is automatic. If available space in the output stream is insufficient, the encode function returns a buffer insufficient status without partial writes. Decoding begins with header validation. The system reads type identifier and version from the input stream, validates against the request parameters, and retrieves the corresponding decoder function from the registry. If no matching codec is found, the decode operation returns a codec not found error and leaves the input stream position unchanged. Error handling within codec operations follows a consistent pattern. All codec functions return a status enumeration indicating success or specific error conditions. The stream corrupted status indicates malformed input detected during parsing. The incomplete data status indicates the input stream ended prematurely before the codec expected additional bytes. Codec plugins may register optional validation hooks using the register validator function. These hooks execute after decoding completes but before the object is returned to the caller. Validation hooks receive the decoded object and return a Boolean success status. If validation fails, the decode operation returns validation failed and may log diagnostic information. The registry maintains metadata for each registered codec including creation timestamp, total encode operations count, total decode operations count, and average operation latency. These metrics are updated atomically after each codec invocation. The getCodec metrics function returns these statistics without blocking concurrent operations. Memory management for codec registration uses reference counting. When a codec is unregistered through the unregister codec function, the system decrements its reference count. The codec remains in memory until no active encode or decode operations reference it. The isSafe to unregister function checks whether unregistration would disrupt in-flight operations. Namespace isolation prevents cross-domain codec name collisions. Each namespace maintains its own identifier mapping. The global lookup function searches across all namespaces in priority order, consulting the primary namespace list configuration parameter. Namespace priority affects resolution latency, as higher priority namespaces are queried first. Thread safety in codec operations relies on reader-writer locking at the registry level. Concurrent decode operations acquire read locks. Registration and unregistration operations acquire write locks, blocking all other operations until completion. The lock timeout milliseconds configuration parameter specifies maximum wait duration before a lock timeout exceeded error is returned. Streaming codec support enables large data serialization without complete object materialization in memory. Stream-capable codecs register a stream encode function accepting a source stream instead of an object reference. The system automatically detects stream codec availability and uses it, when available during bulk serialization operations, to reduce peak memory consumption. Codec caching improves resolution latency for frequently accessed codecs. The cache codec lookups Boolean configuration parameter enables automatic caching of positive lookup results. Cache entries expire after cache TTL milliseconds. The clear codec cache function immediately flushes all cached entries without affecting the underlying registry. The Codec Registry exports a human-readable listing through the dump registry function, which outputs all registered codecs with their identifiers, versions, and operation metrics. This output format remains stable across versions and is suitable for log analysis and monitoring. The optional namespace filter parameter restricts output to specific namespaces, reducing output size.